Welcome to another riveting video. This one's on 3E, which is solving radical equations. So I wrote down the steps here. The first step is to isolate the radical. Get the radical by itself. So if there's any operations on the outside, move them. Then you raise both sides of the equation to a power that is the same as the index of the radical. So if it's a cube root, raise it to the third power. If it's a fourth root, raise it to the fourth power. If it's a square root, raise it to squared. Then you solve the resultant equation and check for extraneous solutions. You guys may not have heard of extraneous solutions, but extraneous solutions are mathematical solutions that end up, when you go back and check them, they don't actually work. So this last step, this is not a step to check your work. This is part of the process. So you only want to really do this, and I'm not going to make you do it for all the problems. Only do it if you if you have a quadratic at some point. So only check with quadratics. So when we get to a problem like that, I'll show you. So example 1, we have a cube root of 4x minus 8, and then all that subtracted 4 equals 0. So the first thing is to isolate the radical. So isolate the cube root. So I'm adding 4. And my handwriting's terrible today. So it's a cube root of 4x minus 8 equals 4. Opposite of a cube root, cube. 4 cubed. $64. So now we have 4x minus 8 equals 64. Add 8. Add 8. 4x equals 72. Divide by 4. Divide by 4. X is equal to 18. You can substitute it back in to check for extraneous solutions, but you're not going to find that it's extraneous. If it does not equal 0, then it's going to be because you did some mental math wrong. All right, example 2. So solving this equation, I got to get the radical isolated. So there's a times on the outside, 3 times the radical, and subtract 9. So in solving this, if you think of the radical as just like a variable, one big variable, you have 3 times the variable minus 9. So that's a two-step equation. You add 9. So opposite order of operations. 3 square root 2x minus 1 equals 6. Divide by 3. You get the square root of 2x minus 1 equals 2. Let's square it. Square it. 2x minus 1 equals 4. Add 1. Now we're actually just solving the equation. 5 divided by 2. X equals 5 halves. We didn't use it. There was no quadratic equation. Didn't use the quadratic formula or factor at any time, so we don't have to check for extraneous solutions. Example 3. So here, let's go with green. Radicals isolated here. So at this point, we're just going to square. So square right away. Square root, opposite is square. So we have opposite is 5 minus x equals x plus 1 squared. Now you gotta remember, anytime you square a binomial, that says binomial times itself. So I always write it out. So now we need to use double distribution. Some of you know it as FOIL. So you get x squared, and if you multiply it all out, you'll get 2x plus 1. And then now we have a quadratic, So once you have a quadratic, you're going to want to move all of your terms to one side. That's an x. All your terms to one side, so subtract 5. Let's do that right away too. 0 equals x squared plus 3x minus 4. So at this point, you can use either this is a quadratic, so we're going to have to check for extraneous. But before that, you can either use the quadratic formula, which always works, but if you can see that you can factor it, why not? It's a lot faster. A is 1, so in this case you're just thinking, what two numbers multiplied at -4 that add up to 3? And that's x plus 4 and x minus 1. Now when you're solving this factor, or this quadratic, all I do is I set each factor equal to 0, because it equals 0, and with multiplication, if one of the factors equals 0, then 0 times the other factor is automatically 0. So that's your goal. So we just want to know what numbers would make each one 0, so subtract 4. X equals -4, and I'm sure you're already saying it, x equals 1. So those are our solutions, but we got to check to see if maybe they're extraneous. So quick check. It doesn't matter to me how you check, but you always have to go back to the very beginning. So if you want to do it mentally, that's fine. So if I check -4, so 5 minus -4, and you take the square root of that, it's got to equal -4 plus 1. So on the left side, that's 9. Square root of 9 is 3. On the right side of the equal sign, it's going to equal -3. Well, that doesn't make sense. So -4 is an extraneous solution, so we just cross it out. Now if you check 1, 5 minus 1 equals 1 plus 1. 5 minus 1 is 4, square root of 4 is 2. The right side, 1 plus 1 is 2. That's good. So x equals 1 is our only solution in this case. Moving on to, let's go past example 4. We'll go to example 5. For this one, we have 2 square roots in the problem. Isolate one of them. So you're going to have to move the other one to the other side. So we're just isolating one radical. And you get square root of 2x plus 3 equals 1 minus the square root of x plus 1. And then now you have it isolated, one of the radicals isolated, so now let's do the opposite of the index. The index is like square root 2. So square 2 square, and we get 2x plus 3, because square and square root are opposites. You get 1 minus the square root of x plus 1, and 1 minus the square root of x plus 1. That's a minus there. Left side just keeps it the same. I do a lot of rewriting just because it's easier for me. 1 times 1 is 1. 1 times a negative square root of x plus 1 is a negative square root of x plus 1. And then another negative square root of x plus 1 times 1 is another negative square root of x plus 1. Those are like terms. That's good. And then negative square root of x plus 1 times a negative square root of x plus 1 is positive square root of x plus 1. Not complicate things, but it's the exact same thing multiplied together, so it's just squared. Because it's x plus 1, or square root of x plus 1 times the square root of x plus 1, so that's squared. Alright, let's simplify this down a little bit. Left side's still the same. Right side, 1 minus, both of these are like terms, so minus 2 square root of x plus 1 plus square root and square cancel, so it's x plus 1 that comes down. Drop the parentheses because that's only needed with the square root. and we're still gathering like terms. So we have 1 plus 1 is 2 minus 2 square root x plus 1 plus x. Keep on going. Well, we still have a radical, so now we have to isolate it again. So subtract x, subtract 2, subtract 2. That's enough for this step. So that's x plus 1 equals negative 2 square root of x plus 1. And then let's divide by negative 2. And then we have x plus 1 divided by negative 2 equals the square root of x plus 1. And now the radical is isolated, so let's square it. Now squaring this side, it's going to look kind of crazy, but I'll try to make it simple. You square the numerator, and then you square the denominator. So if you square the numerator, that's x plus 1 squared, so that's x plus 1 times x plus 1. That's going to give you x squared plus 2x plus 1 in the numerator. Square the denominator, you get 4. And that's going to equal x plus 1. So now, what I'm going to do is get rid of this denominator, so multiply by 4. Multiply this side by 4. You get x squared. I know this looks like this is a really long problem, but there's nothing here that you guys cannot do. So subtract 4x. If you think about each individual step, none of it is incredibly difficult, and you all will definitely get through it. So x squared minus 2x minus 3 equals 0. At this point, you can use the quadratic formula, or in this case we can factor again. So x minus 3, x plus 1 equals 0. And your solution is x equals 3, x equals negative 1. So check in both of them, substitute 3 in, all the way back up top. So I put 3 in for x, 2 times 3, 6, plus 3 is 9, square root of 9 is 3, so I have 3 here. So this is a quick check. 3 plus 1 is 4, square root is 2, and so 3 plus 2 equals 5. That does not equal 1. So 3 is a extraneous solution. So that is not a solution. Check negative 1. So if we substitute negative 1 in, so it's all the way back from the beginning. You have 2 times negative 1 is negative 2, plus 3 is 1, square root of 1 is 1, plus negative 1 plus 1 is 0, square root of 0 is 0, so 1 plus 0 is 1, which equals 1. Awesome. So there's a possibility you could get no solutions. It can happen, and it's not a guarantee that you're going to get an extraneous solution. But in this case, 3 was a negative or extraneous solution, and negative 1 is an actual solution. We're going to skip example 6. We're going long, so thanks for listening.